continuation of the previous video. I would like to explain this pointer using one simple example. See here, this is a member function call. This is written in a main program. So maximum is equal to a dot greater b. So a is object, b is also object. So you are calling the member function for the object a by passing b. Okay. So whenever the greater, nothing but this member function is going to compare two values and it is going to give one answer, and that answer is stored in another one variable. Okay. So you are calling the member function for the object, you are passing the object, so answer is also one object. So this is object, this is also object, this is also object, right? So this concept I explained while we are discussing about operator overloading. See here, a is object. For example, a is one age of one person, so age is 35. b is another one object which consists of a data member age, and that age is 40. And now we are going to compare these two and we are going to store the answer in max, right, which is maximum value, whether a or b. So according to this, the answer is 40 is the greatest value or b is the greatest value. So greater b, this is a member function is calling for a. Then see this member function definition. It's a member function definition. So member function is greater and it has to receive the object. So we have to use a dummy variable x. X is also another one dummy variable, dummy object, which can able to receive b, because we are passing b. So x receives the object b. This is passed by value method. So the ampersand symbol, so whatever changes we are making in the address, automatically it affects the value passed by reference value. What is the data type of this object? Person. Person is a data type. Class, we are creating the class. So person, this is a passed by value method, so dereference operator and dummy object. So this is a member function passing object as argument, and this is belonging to the class person, belonging to the class person. So class name is person, and again it returns the value. So the return value, the return data type is again class name, that is person. The return type is also person. Okay, and it returns the address. It returns the address. That's why we are using this ampersand symbol. Okay, so this is the explanation for member function definition. Then inside, what you are going to do? See here, you are going to check the age. See here, a consists of the data member x, b consists of the data member age, not x, age. A consists of the data member age, b consists of the data member age, and I need the maximum age, correct? So all these objects consist of a data member age. Yeah. Now I am going to compare the two ages. I want to compare the age in A and age in B. Right? Both has the same name. So how you are going to compare these two? So the object for which you are calling, I am calling the member function for the object A. Okay. So for that object, no need to use dot operator to use the data members. Correct? This is for B. I am passing B as the argument. For that data member, I have to use dot operator. Yeah. So data members available in B, I want to use dot operator. I'm calling the member function for this object. No need for dot operator. Okay, so remember this. I'm calling the member function for the object A. I'm going to use a data member in A. So to access this data member, no need to use dot operator because I'm calling the member function for this object. That's why no need to use dot operator. But B, I'm passing this as argument. I'm passing this as argument. So the dummy object is X. I'm passing this as object. So to access this data member, I have to use dot operator. You have to follow this procedure. Okay. So here X dot age, nothing but what? It takes the value from B. Then age, it takes the value from A. So what is the value in B? It is 40, 35. So the statement is true. So return X. So return X, nothing but return the value which is available inside X. So that is 40, this data member. So it is stored in max. It returns a value and it is stored in this object age. So now the answer is age. If this is false, then it returns this pointer. It returns a value present in this address, right? If this is false, for example, 30 is greater than 40. In that condition, this is false. So false means it's coming to here. Return the value which is present in this address. So what is this address? So it consists of the address of the object for which this function is calling. Correct? So now we are calling this function for the object A. So it returns the value present in the address of A. Clear? So now if it is false, return the value which is present in this address. This keyword represents the pointer. So it returns a value present in this address. What is the address stored here? Address of A, because I am calling the member function for A. Hope you would have understood this. I'll go to the next topic. Pointers to derived class. So base class and derived class, we can able to create a pointer. Not only to the base object, but also to the objects of derived classes, we can able to create a pointer. And the base class objects are type compatible. Single pointer variable can be used to point out the object which are coming under different classes. Right? See here, class B, this is class D. Class B and class D. And it is derived here, publicly the B characteristics are derived in D. Listen, class B, class D. Class B, class D. And here it is inherited, the B is inherited in D. B represents base class, D represents derived class. Here we are using single inheritance. Okay. For this we can able to create a pointer. See here. B is a object. B is a object. B is not a object. B is a class. B is a class. So for B, I am creating a pointer. The class, I am creating the pointer. Correct? So the value present in this address. So this is object pointer. This is object pointer. Okay. Then for B, I am creating one object. This is base object. For B, I'm creating one object, base class object. So this is B is one data type, D another one data type. B is one data type, D is another one data type. For the data type B, I am creating the object B. For the data type D, I am creating the object D, correct? B is a base class object, D is a derived class object, and for the base class, I am creating one pointer. This is object pointer. Normally, we will create only objects. In the previous programs, we have created only objects. In this program, newly, I am creating one object pointer. Object pointer. So, the CPTR, this is the address of a particular object. Address of a particular object. That's all. Only I am including a new line B pointer. This is object pointer. This is a class. This is object pointer, and I'm creating. See here, we know that CPTR nothing but it is address. Address. So first address is equal to, it takes address of the base object. Address of the base object. Yeah. Then CPTR is equal to, it takes address of the second object. Okay. So this represents address and this represents the object. Like this, you can create the pointer for the base class as well as for the derived class. So one more point is, CPTR is a pointer for the base class. CPTR is a pointer variable created for the base class. So this is the data type B. This is a data type B, right? But D is the object for the data type D. This is the object of data type D. So you are using base class pointer for the derived class object. Base class pointer for derived class object. This data type is different, this data type is different. But this is possible in C++. This is valid. D is an object derived from the class B. Okay, so this is called as type compatible. Type compatible. The compiler will not give you the error. It is also acceptable. See here, this pointer is created for the data type B. It is a base class pointer. But in this base class pointer, I am storing the address of derived class. Address of derived class object. So this data type is B, but address belongs to the data type D. This is also possible. This is called as type compatible. Hope you have understood this. Any doubt, mail me. Thank you.